First question is calculate the energy of one of the photons of a beam of light having wavelength 25 micrometer. So my first question about this is from Lemuel. What do we mean by 25 micrometer? How we convert it to meter? Lemuel, you need to unmute your mic.
Yes, sir. Sir, 25 micrometer means 10 raised to the power minus 6 meter.
Right. So you will multiply it by 10 power minus 6 to get meters, and then you will use it. Then next question to Ariman Pal. Which formula you will be using here? Many hands have been raised. Okay. Amir, Yash, Bedi, Samad, Pratham, Arjun, Atman, Avesh. Yes, I am looking answer from Ariman. Unmute your mic. Tell me the answer. Which formula you will be using? Okay. Now I am giving chance to those who have raised hand. Arna, yes, tell me. Arna, which formula you will be
So
using?
we'll be using the energy of photon formula.
What is that?
E equal to hv. I mean energy equal to.
New, right? New.
Yeah, yeah.
H mu.
You will use specifically for lambda. Although if you say equals to h nu, that is fine because you will be converting nu to c by lambda. So you will actually be using E equals to hc by lambda, which is also E equals to h nu, and you will get the answer. The only thing that you need to ensure you are using correct units, convert this micrometer to meters, and then you will get the answer in joules. Next question. When light of a wavelength 470 nanometer falls on the surface of potassium metal, it is photoelectric metal. Electrons are emitted with a velocity. What is the minimum energy required per mole to remove an electron from potassium metal? Before I start, what precaution you need to, what is asked actually in this question? There is a specific point where students make mistake. Okay. So you need to tell me that will you just apply the formula, or to get the answer you have to do something else also apart from applying the formula? Okay, those who have raised hand, Pratham, yes, tell me.
Sir, in this case, sir, first we'll have to convert the wavelength, sir. Uh, and sir, like the formula would be no, h nu equal to h nu naught plus half mv square.
Right.
So, sir, here we have been given the velocity, and we'll apply the sir, we'll put the value of mass 9.1 into 10 to the power minus 31. And sir, here we have also been given the wavelength. So from that we can also calculate h nu. So sir, then we'll have to find h naught. And sir, then per mole, so sir, we'll have to divide it.
Divide? Are you sure?
No, sir, multiply, sir. Sorry, it is for one atom. Sir, we'll have to multiply.
Whole answer actually wrong if you divide it, right? So you need to be cautious, and that is the mistake. That's why I asked, right? Either students don't multiply or they divide sometimes. So here velocity is given, kinetic energy you can calculate. Okay. Then you can apply energy of the photon this much. Very simple formula. Very simple formula you have to use here. And see what I am saying here. Okay. Now you use E equals to E naught minus kinetic energy, or you can directly substitute the values here. Okay. Instead of first calculating, you can directly substitute the value.
Yes, sir.
Okay. And once you get the value, you have to multiply it by
Okay.
0
By
to
mole.
to get it per mole. And this is the part where students lose marks. Despite me telling again and again that you always see what is asked. A very important point. You need to just use this formula, everything is given. Next, how many photons of light having a wavelength 400 nanometer are necessary to provide 1 joule of energy? This is very straightforward formula based question, nothing else. So I need answer from uh, Vedant. Yes, Vedant, tell me, which formula you will be using here? Vedant, yes, which formula you will be using? Almost everyone has raised hand, okay? So easy question. No, no, you can't get unlimited time to answer it. Okay. Next, I will be asking for this one. Yes, Sanskriti, which formula you will be using here?
So E is equals to H mu.
Okay. Here wavelength is given. So just modify that to Hc by lambda. So you can use directly Hc by lambda instead of writing h nu and then converting that to Hc by lambda. Good.
Sir, it would be NHC by lambda, no?
Mm, it is because we have to calculate how many. So first we are calculating one photon. There is different ways. Okay. So it is for
Yes.
one photon. That's why it is written.
Yes,
Hc
sir.
by-
So we divide by 1
Yes. So
and divide from
this
1.
is energy provided
So
by
then
one
we'll
photon.
divide by 1.
Yes. So we will say that 1 joule of energy will be provided by how much? Either you use the formula, you know, Et is equal to NH nu or Hc by NHc by lambda. That will give you same answer. Here Et you need to substitute as 1, N, and Hc by lambda you know the value. So effectively N will be 1 divided by Hc by lambda, which is E. So that's what you have done. 1 divided by whatever is the value of Hc by lambda. Anyone not clear about it? Let me know what I am saying. Yeah. You can do the same question as total energy will be n times energy of one photon. Okay. So 1 is equal to n times 6.626 into 10 to the power minus 34, 3 into 10 to the power 8 divided by lambda 400 into 10 to the power minus 9. So from here you will get the same answer, number of photons. Next question, when electromagnetic radiation of wavelength 300 nanometer strikes a metal surface of sodium, electrons are emitted with a kinetic energy of this. Kinetic energy is given, wavelength is given, wavelength of incident radiation. Okay, so lambda is given, not lambda naught. What is the minimum energy needed to remove an electron from the sodium? Minimum energy is required. Now, this time I'll give chance to those who have raised hand. uh, Naman, your mic and video are not working. So you can respond in chat window. Tell me which particular formula you will be using. What will be the approach? First part. No? Naman, am I audible to you? Okay. Uh, no, Naman, this is not the main formula you will be using. I'm giving chance to Amir now. Yes, Amir.
Yes, sir. So first you will divide the kinetic energy by Avogadro's number so that we get it per electron. And then, sir, we will use the ET is equal to E naught plus half mv plus kinetic energy formula.
Right. Good. The question is, what is the minimum energy to remove an electron? An electron. However, the energy, kinetic energy is given for 1 mole, means for 6.022 into 10 power 23 electrons. So you will first convert the kinetic energy for 1 electron. You will say kinetic energy for 1 electron will be 1.68 into 10 to the power 5 divided by 6.022 into 10 to the power 23 joules per atom. This kinetic energy you will use in E equals to E naught plus kinetic energy. So kinetic energy is known. This E you can get from 300 nanometer hc by lambda equals E naught plus whatever kinetic energy for 1 electron you have obtained. Substitute only E naught, minimum energy required for an electron is unknown. You will get the answer. So first, this is the total energy. E equals to hc by lambda. We calculated the energy of the incident field, E. Kinetic energy we will get by dividing this by Na, Avogadro number. E naught will be their difference. So kinetic energy we calculated for 1 electron dividing by Avogadro number. After this, we just applied the formula E equals to E naught plus kinetic energy and get the answer. Next part is what is the maximum wavelength that will cause a photoelectron to be emitted. Maximum wavelength will correspond to the, in this case,
So minimum energy.
minimum energy. Good,
Lambda not equal to hc by E naught.
good.
You know.
Lambda naught will be equal to hc by E naught. So it will be, because this is minimum. So if this is minimum, lambda naught will be maximum. Substitute the values. This you have obtained anyway. Substitute these values and get the answer. Next question, a photochemical reaction requires this much energy per molecule. Calculate the number of photons per molecule of light with wavelength 250 nanometer that is just sufficient to initiate the reaction. Sorry. Now this is actually not exactly photoelectric effect, remember. Okay. This is a photochemical reaction. Reaction happening. Photochemical reaction is something which you see, for example, monochlorination of hydrocarbons. So suppose you have CH3, you get it reacted with Cl2 in sunlight. Okay, so this reaction takes place in sunlight only. So sunlight has UV rays. So in UV rays, you get CH3, CH2, Cl, monochlorination. So this is a reaction type we are talking about here. So don't get confused that we are talking about photoelectric effect. It is actually reaction. It requires this much energy per molecule. Calculate the number of photons per molecule of light with wavelength this much. That is just sufficient to initiate the reaction. A few students have raised hand. See, okay, this time I'll allow Kavish to answer. Yes, Kavish.
Yes, sir. So we'll use E equal to NH C by lambda, and energy and wavelength is given to us.
Okay, anyone else? Just if you can add one statement, otherwise it's fine. Yes,
So
Prakash.
won't we be using the kinetic energy formula?
So to Samad, yes, you want to add something?
Sir, won't we be using the kinetic energy formula in this?
Kinetic energy formula. Okay, how?
So because it is asking,
Hmm. It is asking about the number of photons per molecule of light, which will have sufficient energy to initiate the reaction. So basically, it is asking the calculate the number of photons because if you increase the number of photons, there will be greater amount of energy. One photon has some energy, two photons will have double the energy. So the question is asking how many photons you actually need to start the reaction. It requires 9.6 into 10 to the minus 16 joule energy. It is given.
okay.
Okay. Yes, Aryamanpal.
Sir, like, do we use the energy like 9.6 divided by the energy of per molecule of like per photon of light?
Right. Okay. So all answers are correct, right? There was a query that was something, different, but the answers are correct because what you have, the reaction requires, say, this much energy. 0, 9.6 into 10 to the power minus 16. This much energy is required. One photon say can provide this much energy, two photons will provide this much, three this much, four this much. So it is asked that if we can calculate the energy of one photon, then it is asked how many photons we will need total so that the total energy will be equal to this one, because this is the energy required by the reaction to initiate. So we can calculate energy of first one photon by using this wavelength. Wavelength is given and energy of the photon will be hc by lambda. So we will divide total energy which is required by energy of one photon to get the number of photons. So energy of one photon will be based on its wavelength. We can calculate because hc anyway we know lambda is given. This much energy is of one photon. Total energy is given. Number of photons will be total energy, that is for per molecule, divided by energy of one photon. So it can be in fraction. So if suppose your answer comes out to be 120.3, even then you won't round it off to 120 because this 0.3 will be provided by another photon. You can't have photon in fractions. So don't write answer as 120 by 3. This is something a few students have done this mistake in past. So if answer comes out to be in fraction, you need to add whole one photon for this 3. So the answer will be 121, not 120 rounded off.
Okay.
Next question. A 100-watt bulb emits electromagnetic. Now this question I am doing third time. Everyone should be able to answer this question. A 100-watt bulb emits electromagnetic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. Who will answer this question? Yes, Pratyush.
Yes, sir. So please use the formula. Energy is equal to hc by lambda.
Pratyush, just come closer to your mic. You are barely audible.
Sir, we'll use the formula hc by lambda.
Okay, then it's not a straightforward hc by lambda. Why?
Sir, may I?
Sir,
Okay, Shashwat, yes.
Sir, first we'll calculate the energy of one photon, and then we are given the energy of the bulb in watts. So that will be the energy emitted by the bulb per second. So from there, we can calculate the number of photons emitted per second.
Right, good. So basically total energy is given. 100-watt bulb means total energy is given, means watt means energy per second. And photons emitted per second asked. So it is given that total energy is 100 watts, that is 100 joules per second. So in 1 second, how many photons of this wavelength will be emitted? Okay. So suppose you have energy of 1 photon. So again, a similar question. So if it is n number of photons, you can calculate energy of 1 photon. And energy of 1 photon will again be given based on lambda, will be Sc by lambda. So energy of 1 photon is Sc by lambda. You will get total energy is this much. How many photons will be able to produce this much energy? Just divide 100 by energy of 1 photon. Is that clear or not? If there is any confusion, anyone, don't hesitate. You are not
So
going
can
to
you
lose
please explain
marks.
it again?
Yes. 100 watt is the energy, total 100 watt means 100 joule in 1 second. Question is, and this is bulb, okay, by bulb. So bulb is emitting this much light, okay, 100 joules in 1 second. Now question is, it emits electromagnetic light of wavelength this much, but this wavelength of these rays is 400 nanometer. So it means this will consist of photons. Say suppose there are n photons, total energy will be 100 joules of these n photons. Now on the basis of the wavelength of this radiation, you can calculate the energy of 1 photon. So energy of 1 photon in this radiation will be Hc by lambda. (400 into 10 to the power minus 9). This. So when you calculated E1, and this is energy of 1 photon, and there are n photons, so n times E1 will be equal to total energy 100. So n will be 100 divided by E1. Whatever you have calculated this value, substitute that, you will get the answer. These many electrons, photons will be there. Calculate the wavelength, frequency, and wave number of a light wave whose period is 2 into 10 to the power minus 10 seconds. Now I need answer. Okay, I'll give chance to Arjun. Yes. Tell me. How
Oh,
will you
yes,
get?
sir. Time period is given, so frequency is the reciprocal of time period. So from this we can calculate the frequency, and then wavelength we can calculate by c by nu, and wave number is again the reciprocal of wavelength. So we can calculate wave number also.
Right. Good. So here you have frequency equals to 1 by time period. And the moment you have frequency, you can use lambda equals to c by nu. Okay. The formula given is nu equals to c by lambda in book. The same thing, lambda equals to c by nu. You get the wavelength. The moment you get wavelength, wave number will be 1 by wavelength. Next, what is the number of photons of light with a wavelength of 4000 picometer that provide 1 joule of energy? Again, the similar question we have done. Total energy is 1 joule. Suppose you have n photons here. N photons. Energy of 1 photon you can find from this wavelength. So energy of 1 photon will be Hc by lambda. H known, C known, lambda from here. Okay. So n times energy of 1 photon will be total energy, 1 joule. So from here you will get n. Energy of 1 photon you calculated this much. This multiplied by n will be total energy. So n will be Total energy divided by energy of one photon. Next, a photon of wavelength 4 into 10 power minus 7 meter strikes on metal surface. The work function of the metal is this much electron volt. Calculate the energy of the photon in electron volt. Who will tell me the precaution to be taken here and the factor also? Just a second.
So first we have to convert the energy whatever we have obtained into electron volts by dividing it by 1.602 into 10 minus 9.
Yes, correct. Okay. So first you need to make sure that you are converting the units to just one unit system. Now here it is given the wavelength in meter. So yes, that is fine. You can calculate the energy. The work function is given, wavelength is given, lambda equals to 4 into 10 to the power minus 7 meter. From here you can calculate E equals to Hc by lambda of the incident beam. Then work function is given, work function means E naught is given 2.13 electron volt. The value of E you get from here, because it is in meter, all SI units, you will get in joules. So make sure that you convert that to electron volt. So energy, this one in electron volt will be whatever you have E
3.1.
divided by 1.6 into 10 to the power minus 9. If you want to convert energy in joules to electron volt, you will divide it by 1.6 into 10 power minus 19. If it is in electron volt, you convert to joule, then you need to multiply by the same factor. And this is basically 1.6 into 10 power minus 19, nothing but the charge on proton or positive of the charge on electron. So once you have in both in same units, then you can calculate the energy, okay, the kinetic energy of the emission and the velocity of the emission. Yes, how you do it? Energy of one photon, Sc by lambda, it is 4.97 into 10 power minus 19 joule. So remember here it is in joule. You will convert it by dividing it by 1.6 into 10 power minus 19 to electron. First part, the energy of the photon in electron volt. Done. Yeah. Then the second part, the kinetic energy for that, E is known, sorry, E has been calculated 3.1. E naught is known, given. Kinetic energy can be obtained. Just substitute the values. Obviously in electron volt. Third one, the velocity of the photoelectron. For that, you need to convert this into U, because kinetic energy, when we say kinetic energy equals to half mv square, and we need this velocity. And we have calculated the kinetic energy. We can't substitute this kinetic energy in this formula because here the units of mass will be in kilograms and velocity will be in meter per second, which are SI units. So you have to convert this also in SI units. So you will use 0.97 into 1.6 into 10 power minus 19, then equals to half 9.1 into 10 to the power minus. You will use in kilograms 28 into minus 31. That will be the answer. In few cases, you will be given this mass, remember. Okay. In few cases, some other particles might be given, and by mistake, don't use the mass of electron in that case. So the third part will be this one. You need to multiply 0.97 by 1.6 into 10 power minus 19, so that you have this energy, kinetic energy in joules. That's why this factor has appeared here. Common mistake here. Any confusion? Let me know.
No, sir.
Okay. Otherwise, please keep your mics off. Just check whether your mic is on mute or not. Next one. A 25-watt bulb emits monochromatic yellow light of wavelength of 0.57 micrometer. Calculate the rate of emission of quanta per second. Who will tell me answer of this question? We are doing this question second time. Okay. The 6 hands raised, but I'll give chance to who raised hand first. Ariman, yes. Tell me the answer. Unmute your mic before you speak. Ariman, I can't hear you.
Yes, sir. Could you just give me a second?
Yeah. It is actually very easy question. Nothing more to be done. Whatever is given is sufficient to get the answer. Okay, I transfer it to Yash Bedi.
So here we will use the formula A is equal to NH nu, and its 25 watt will be taken as the energy as it is per second.
Right. Because 25 watt is given, it means this much energy per second and quanta per second hour. So whatever number of photons you get, those will be emitted in 1 second. So nothing extra to be done. 25 watt means 25 joules per second energy. So whatever energy is this one will be releasing or emitting the photons. Those photons will get emitted in 1 second. Okay. Don't forget to convert wavelength to meter. That is multiplied by 10 to the power minus 6, and you will get the answer. So energy of one photon, you got hc by lambda. This you converted to meter. You got it in joules. Okay. And 25 watt means 25 joules per second. Total energy, that's 25 joule divided by energy of one photon, will give you number of photons emitted, but it will be number of photons emitted per second because this much energy is used per second. Next, how much energy is required to ionize a hydrogen atom if the electron occupies n equals to 5 orbit? Next, compare your answer with the ionization enthalpy of hydrogen atom, energy required to remove the electron from n equals to 1 orbit. So who will tell me the answer to first part? How much energy is required to ionize a hydrogen atom if the electron occupies n equals to 5 orbit? So it is already in excited state, remember. Okay, okay, quite a few hands raised. I'll give chance to, okay, Gyanendra has raised hand this time. So, okay, yes, tell me the answer.
Sir, first we go by the formula such that energy in the nth orbit is sir, 21.8 into 10 to the power minus 19 upon n square. So, sir, and then sir, the change in energy would be E2 minus E1.
What is E2? What is E1?
Sir, E2, sir. Sir, N1 would be 1, and sir, N2 would be.
Okay, I transfer it to. I transfer it to next Samad. Yes, Samad.
Yes, sir. Sir, I was going to say the same thing which he just said. We use the same formula, minus Rydberg constant upon one upon n square initial. That will be 1, and 1 minus n square 5, n square of 5 per square, that is 25.
May I?
Sir, may I?
Sir, may I?
Sir, may I?
I would give chance to Arjun. Yes.
Sir, we will use the energy formula for first calculating the N is equal to 5 for the ionization energy. Sir, the formula would be the Rydberg's constant, which will be 2.18 into 10 to the power minus 19 into
2.18 into 10 power minus 19. Are you
minus
sure?
10, 2.18 into 10 to the power minus 18 joule into 1 upon infinity square at N2 and 1 upon 5 square, which is N1. And so we will get the energy in joules, and then we will calculate the ionization energy from N is equal to 1 orbit, and for comparing we will divide the first answer by the second answer.
Okay, good. Instead of dividing, we say we will have a ratio of. So, but for comparison, we
Yes
say
sir,
ratio.
same thing.
Right?
Yes sir.
Value
It
of
is same
RH,
thing,
sir.
but we say it ratio. Good. Good. So basically, it is just a straightforward formula in first case, because you have electron already in fifth state, and you need to move it to n equals to infinity. So remember, when we are talking about ionization, means electron is going out of the atom. If it is going out of the atom, n is infinity. So n1 is 5 and 2 is infinity. Okay, so it will be delta E equals to E2 minus E1.
So wasn't the formula RH 1 upon Ni square minus Nf square
Yes,
minus 1 upon N square?
actually it is E2. When you write E2, it will actually be minus RH 1 by N square. Yeah, that is actually that. So substitute those values. E2 will be minus RH upon 2 square. It will be minus RH upon N1 square, because it is hydrogen atom. You won't consider atomic number. Now this one will be 0 anyway, because N2 is infinity. This one will be 0. Minus minus will be plus RH 2.18 into 10 to the power minus 18 divided by N1 square, that is 5 square. That will be delta E. To simplify this one, this much energy will be required for this. Okay. Now sometimes too, because in these type of questions we need to compare, instead of just writing delta E, we write delta E 5 arrow infinity, just to show that which
Sir, I had a
transition
doubt.
we are talking about. Yes.
Sir, what would happen if we would use the direct formula? Would it become long?
No, that's not wrong. You can use direct formula. Exactly fine. Okay. Same thing. It is same thing. Basically, you get the same formula. If you combine, if you take RH outside minus RH outside, it will get converted to that formula. Okay. So it is absolutely fine. Yeah, no problem.
So,
Yes.
so can we just use the formula of Rydberg's constant into Z square by N square?
Uh, you can use, in that case, you will have to use atomic number as 1, because
Yes.
it is hydrogen. You
And
can
Z
use.
is 5.
Yes.
Okay.
Now in second case, it is written that you have to move it from first. So instead of fifth, it is in n equals to 1. So same thing you will do, but in this case, n1 will be 1, n2 will be infinity. So you will get another delta E from 1 to infinity, something. Now for the comparison part, you will say that the ratio. Okay. So ratio of, compare with the ionization enthalpy of when it is 1. So you will, when you compare, you will compare it with E1 to infinity divided by E5. This ratio you will calculate. That will be the answer. So in first case, this is the formula. Okay. Although I have written here E2 minus E1, I have used the formula directly. And if you want, you can use Z square also. Okay. Not a problem. But you will have to use that as 1. So you get the answer. Similarly, for first to infinite, n1 is 1 here, not 5. Substitute the values, you get the answer. And for comparison, you have the ratio. It means it will be 25 times. So when you remove from first orbit, the energy required will be 25 times as compared to the energy required to remove when it is in fifth orbit. That much high energy will be required. Next, the mass of an electron is given if its kinetic energy is this much, calculate its wavelength. Who will tell me which formula you will be using? Which formula you will be using? Okay, I need answer from. I'm getting hands raised, mostly by a defined set of students. Others are not raising hands. So usually I'm getting hands raised by, Yash Bedi, Arjun, Piyush, Ektam, Shashwat, Amar, Ariman, Amir, Kavish. Others, tell me the answer. Which formula you will be using here? Okay. Devanshi, tell me the answer. Which formula you will be using?
Wavelength equals to h upon mv.
Come again.
Sir, am I audible now?
Yes, you are audible. I think it was a bit sharp voice. Yes.
Sir, wavelength equals to h upon mv.
Okay. What is that formula called? What is given by that formula? This wavelength is called what type of wavelength?
Sir, may I answer?
Yes.
Sir, de Broglie's wavelength.
Okay,
Yes,
correct.
sir.
That is called de Broglie's wavelength. So use the formula. Kinetic energy is given here. In this case, so kinetic energy, you will get the velocity. The moment you get the velocity, you will use the de Broglie's formula, h by mv.
Planck's constant upon momentum.
Yes, correct. Planck's constant divided by momentum gives you the wavelength. Next, an atomic orbital has n equals to 3. What are the possible values of L and M? Okay. So quickly, many hands raised. It means confidence level in this section seems high. Okay, yes, I have got Lakshya here. Yes, Lakshya, you have raised hand. Tell me the answer.
Yes, sir. Sir, here we have given sir principal quantum number as 3. So, sir, the possible values for sir, first we will calculate for ml, sir, which will be 0, 1, and 2.
ML or L?
Yes, sir. Sir, sorry, sir. Sir, L, sir, which will be 0, 1, and 2. Sir, I think that I'm doing so.
Okay, I pass it on to Karthikeya.
Yes, sir. For n equals to 3, we will have the values of L as 0 to n minus 1. That is here 0, 1, and 2. And for every value of L, we will have different values of m from minus L to L.
No, good, correct answer. Meanwhile, I had received correct answer for this one from Samad as well in the chat window. The previous one I had received in chat from Pratyush, Naman. Good. Fine. So here n equals to 3. L is from 0 to n minus 1. That is 0, 1, and 3 minus 1, 2. We will stop here. Then for all these L values, you will have M values. Okay. So how you will be writing it? In exam, if this appears, you will draw the table. We will say for n equals to 3, L will be 0, 1, 2. And then you will have corresponding m values. You will write 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. Like, don't just write statements. Draw the table, it will be sufficient to answer the question. List the quantum numbers m and l of electrons for 3D orbital. Who will answer the question?
Sir, can I tell Lakshay?
Sir, can I?
Sir, can I tell?
Okay. Okay, who wants to tell? Just say again.
Sir, can I tell Lakshay?
Sir, can I tell?
Samad, Lakshya. Okay.
May I?
Because last time I was not satisfied with the answer given by Laksh. So next again, Laksh, yes, tell me the answer.
Yes, sir. Sir, for electrons for the 3D orbital, sir, we know that sir, for D it is 2. So, sir, L will be equal to 2. And, sir, ML will be minus 2, minus 1, 0, plus 1, plus 2.
Okay. Right. So L is D. It means it is 2. And M will be minus 2 to plus 2. Correct. Now the third part. Which of the following orbitals are possible? Who will tell me the answer?
Sir, can
Sir, can I?
Okay, Pratyush, yes. Pratyush,
Sir,
yes.
2s and 2p.
2s and 2p. Okay. Now, my question is to my question is to Gyanendra. Why 3f is not possible? Gyanendra, tell me why 3f is not possible.
So may I?
Just let me wait for a few
Sir, can I
seconds.
tell?
Just a second first. Let me force Gyanendra to answer. Gyanendra, are you listening to me? Why 3f is not possible? Okay. Samad, because you have already
Yes, sir.
responded in the chat window, so I am not asking. Gyanendra is ringing me. Just let me check. He wants to answer on phone. Yes, Gyanendra. Yes, I can. Yes, I can hear you. Your answer is correct. Reason is not correct. Okay. Okay. Now I give chance to Pratham Banerjee. Yes, tell me the answer. Reason.
So reason for 3f is not possible, sir.
Yes, why?
Sir, because the principal quantum number for 3f is 3 as we know. So, sir, the maximum possible value will be 2. And, sir, f does not correspond to that. So, sir, 3f is not possible.
No, you can't just say maximum possible can be 2. You have to justify why it will be only 2. Okay, Shashwat has given me correct answer in the chat window.
Yeah.
Sir, for
yes,
because
tell me
n
the
minus
answer, yes.
because of the formula n minus 1, according
Okay,
to that.
Right. Now correct. So you have to justify in all such cases, otherwise you will lose marks.
Yes,
Don't just write the values. You have used some concept, some point to prove that it cannot be greater than 2. To say that when n is equal to 3, then L can be 0, 1, 2. That is S, P, and D only. That's how you will write it. You have to write it if it is asked. Yeah. Next, explain giving reasons which of the following sets of quantum numbers are not possible. Not possible, you need to tell me, not the possible one, okay?
Sir? Sir, in the first one, it is plus 112, or sir, it will be plus 1 by
1 by 2. It is 1 by 2.
Okay.
Just one. quite a few students have raised hand. Yes, Shivani, tell me which are not possible, not correct, and reason also. Shivani, I can't hear you. Okay, I need reason as well. So I'm just passing this question to Subway. Yes, Subway, you have raised hand.
Yes, sir. So it will be C and E. So because value of n cannot be equal to value of L. So the L value should be 0 to n minus 1.
Okay. So C and E, okay. Fine. Anyone else? C and E, fine. Yes, correct answer. Yes, C and E, not possible. So understand it. For n equals to 1, L can be 0, this can be 0, this can be plus half, absolutely fine. For n equals to 1, obviously 0, 0 minus half, fine. For n equal to 1, L can be 0 only. This one, this part not possible. So that's why it is wrong. For n equal to 2, L can be 0, comma 1. 1 is possible. For this one, I'm 0 minus 1 by 2 possible. N equals to 3, L can be 0, comma 1, comma 2 only. This one not possible. Okay. And at the same time, when this is not possible, this is also not possible. M equals to minus 3. N equals to 3, L can be 1, M can be 0, can be 1 by 2. So absolutely fine. Okay. However, this one is written A here because I have changed it. A is absolutely fine. I have changed the question. Next, how many electrons in an atom may have the following quantum numbers? You need to tell me the number of electrons which can have this value of principal quantum number and spin quantum number. Who will tell me the answer? I am just seeing who has raised hand, and on that basis, I am asking. Yes, Ariman, tell me the answer.
So am I audible?
Yes, you are audible.
Sir, so what we would do is like to take all electrons available and like n is equal to 4 and then half it because they cannot only have a square spin quantum number of plus half.
Okay, so what is the answer?
Sir, it'll be
You are muted.
sir, will it be 9 electrons?
No.
Sir, may I answer?
Sir, may I answer?
Where can I tell you?
May I?
Okay.
Sir, may I answer?
Well, 3 students, Shashwat, Pratham, Kartike. Okay, I will give chance to Kartike. Yes.
Sir, here for n, we will find the total number of electrons, that is 2n square. And for spin quantum number half, it would be half the total number of electrons, that is n squared. So total number of electrons will be 16.
4 square means 16. Correct. So total number of electrons in a shell given by 2n square. Electrons in nth shell will be 2n square. The total will be 2 into 4 square, that is 32. But with spin minus half will be half of it. 16 electrons. Next, n equals to 3, L equals to 0. How many electrons will be there? So if you have raised hand for previous question, make sure that if you don't want to answer, you drop it first. Okay, I give chance to, yes, Arna, tell me answer for B part. N equals to 3,
So
L equals
2
to 0.
electrons.
Okay. Why?
So because n equal to 3, L equal to 0 means 3s orbital, which can have only 2 electrons.
Right. Correct. So this is s orbital of third shell, and s orbital has only 2 electrons. That's it. Next question. What transition in the hydrogen spectrum would have the same wavelength as the Balmer transition in n equals to 4 to n equals to 2 of helium spectrum? There are only 2 questions of this type, so you can memorize. But that's why, because you can memorize, you need to explain how do you get the answer. You need to explain the process, the steps. So you need to raise hand, and those who can answer this question, it means those have actually done this chapter. If you can explain how to get the answer. Okay, only 6 students have raised hand. I will give chance to Shashwat. Yes,
So we'll use the wave number formula to calculate the wavelength from 4 to n equals to 4 to n equals to 2.
Okay.
And then, sir, we'll replace that wavelength in the hydrogen, and then we'll use the formula of a wave number for hydrogen, and then we'll do a bit of trial and error, and we'll find the answer.
Okay. How can we combine few steps? I am giving now chance to Arjun. Yes, Arjun. How can you save time?
Sir, may I say?
Yes.
Sir, to save time, sir, we don't need to put the values for RH, sir. We just need to calculate out the values in the bracket, sir, which we have put for the values of n. And sir, then we'll have to equate, then we'll do hit and try.
Right.
So value of R would get cancelled simply.
Right, right. So basically what you need to do to save time in such questions, if it is, we are talking about same wavelength, means wave number will also be same. If wavelength is same, 1 by lambda will also be same. So you need to say wave number 1 is equal to wave number 2. That is RH 1 by 2 square minus 1 by 4 square, okay, of helium. Means here you have to use Z square. Okay, you
Sir,
have to use.
it would be 4, no?
Come again.
So like Z square by n square. So according to that, it would be 4, no?
Yes. So here you will say it is 2 square equals to RH 1 by n1 square minus 1 by n2 square, and this is for hydrogen. So leave it as it is. Now calculate this part, 1 by n1 square minus 1 by n2 square. RH got cancelled. And try to have some trial and error method. Start with n1 1, n2 2, then n1 1, n2 3, n2 2, n2 3, okay, or 4. Don't do more than 2 transitions. Okay, difference will not be more than 2 normally, and then you get the answer. Yes, Pratyush, that is the answer. In this case, answer will be 1 to 2. In case of hydrogen, the transition will be from 1 to 2. So this one is separately I have written and then I have equated. Okay, you can directly equate this one and this one. RR will get cancelled. Substitute the values, and the answer will be n equals to 1 and n2 equals to 2 when you solve it. So obviously I have not solved it. You have to solve it if this question appears. Next one, indicate the number of unpaired electrons in phosphorus, silicon, chromium, and krypton. For that, obviously, you need to know their atomic numbers. 15, 14, 24, and krypton is noble gas. So you can directly write, if you want, that as krypton is a noble gas, it will not have any unpaired electrons. Yes, who will answer for chromium? I am looking answer only for third one, chromium. How many unpaired electrons are there in chromium and why? Answer I need from Arjun. Yes, Arjun. Unmute your mic.
So can I tell afterwards?
Yes, sir. Sir, I was calculating, sir. Sir, like sir, first we will write the electronic configuration. So it will be argon, then 4s1 and 3d5. So the number of unpaired electrons will be 6.
Okay, fine. Because this is a type of exception where one electron moves from S to D, 4s to 3d, so that it will have half-filled configuration. So total unpaired electrons 6.
Excuse me, sir.
Yes.
Sir, could you please once again explain why does the electron shift from 4s to 3d?
Okay. In case of krypton, sorry, in case of chromium, it is 24. So the usual, which you will think that the configuration should be, which is actually wrong, will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, 10, 10, 4, 24. But what happens? 4s and 3d. Okay, 4s and 3d are very close in energy. Means the electron requires very small amount of energy to move from s to 3d, 4s to 3d. So in such cases, only in those cases where the energy required to move an electron from one orbital to another orbital is very less, this type of transition can take place where the configuration will become more stable. So if we see this configuration, this is 4s2 and 3d4. This configuration is not much stable because the D is not half filled. In this particular case, the energy required by electron to move to D is very low, and when it moves to D, D becomes half filled, which is very stable configuration. So that's why in this case, in case of chromium, one electron moves from S to D. So instead of 4 unpaired electrons, it actually has 6 unpaired electrons, and that's why it has greater paramagnetic character as compared to its theoretical value. So normally, paramagnetic character depends on number of unpaired electrons. So if we consider only 4 unpaired electrons, its paramagnetic character will be something, but its actual, in reality, paramagnetic character is higher because of this exception. So the same question can be asked differently like this also, that why chromium has higher paramagnetic character than its theoretical value. The theoretical value is something like this, but actual is 4s1, 3d5. So it has 6 unpaired electrons. That's why higher paramagnetic character. Both the questions, same underlying cause. Is that clear? Or any confusion, which
Yes,
point
sir.
is not clear, let me know.
So it's
Now, next question. Which of the following do and which do not make sense? With reason. I am not looking answer just numbers or yes or no. I am looking with reason.
Sir, can I tell?
You need to tell me which do not make sense and why.
Sir,
Which do
can I
not
take?
make sense and why. Vedant, okay, tell me the answer.
Sir, 3s3.
3s3. Okay, why?
Sir, because s orbital can only fill up to 2 electrons.
Okay. That is one. There are
Sir,
more than
2D.
one. Okay.
Sir, 2D also.
Sir, 2d, sir, because 2s and 2p is only possible.
Yes, sir.
3p y3 also.
L is equals to 2 also, which is not possible.
Okay. Who said 3p/3?
So Savya.
Okay. Yes, Sabir. Why?
So because it can only hold 2 electrons in it.
Right. Here
So
it is
y
not
orbital.
3p, it is 3p. Why? And when I am talking about 3p, why? It is just one orbital. This is px, py. So py has only 2 electrons. So it cannot have 3. Wrong. S cannot have 3. Wrong. 2 cannot have D. Wrong. So only 7p and 4f make sense. These three do not make any sense.